Good day everyone, this is Daniel again, and in this video we'll be discussing on linear velocity as it is written in the screen there. um when I mean linear velocity, just a straight line velocity in one direction. So that's what we'll be talking about. So what do we define as linear as it is written in the screen? We define linear as a straight line, therefore we shall concentrate on straight lines. So in this video we'll focus more on straight line. It could not just be velocity, other things might just be based on straight line until probably when we're about to say on something else, I might let you know about it. Now let's talk about velocity. What do we define as velocity? According to what is there on the screen, velocity can be defined as the rate at which the position of an object changes with respect to time. It simply refers to the speed of an object, that is, how fast or how slow an object is moving. Now let me explain what was written here. When we define velocity, I mean in terms of science or physics, we can define velocity. That is the first sentence that was made there. Velocity can be defined as the rate at which the position of an object changes with respect to time. I mean, this could be the other definitions. Will say our velocity might look somehow like this. It's just rate of change, the distance moved with respect to time, the rate at which an object is being displaced with respect to time. All those things are the physics definition, and they're actually correct. But like, let me break it down to exactly what it means, and that is where we have our second our the next sentence there. He said it simply refers to the speed of an object, that is, how fast or how slow an object is moving. That is what velocity actually means. That's when we are talking about the velocity of an object, we are just talking about how fast or how slow is it moving. I mean, velocity just has to do with motion of an object. As long as an object is moving, as long as an object is is undergoing motion, then we say that there is a velocity. So that's why it's just the speed of an object, whether it's moving fast or whether it's moving slow. As long as it is moving, we say that this object is exhibiting velocity, of this object has velocity. Okay, what are the types of velocity? We have two types of velocity, or should I say we have two main types of velocity, which is the uniform and the non-uniform velocity. I'll be explaining it one after the other. I'll talk about the uniform and then I'll talk about the non-uniform. Now let's talk about the uniform velocity. With what we can see in the screen there, for a uniform velocity, the object covers equal distance at equal time. That is, it's moving at the same speed. This simply means that the object is not getting faster, neither is it getting slower. Let me explain this. When they say it's covering equal distance at equal time, it simply means it's just moving at the same amount of speed. It's not moving fast. It's not actually increasing its speed, neither is it decreasing its speed. It's not getting faster, it's not getting slower. It's just moving at that same speed is moving with. Let me give an instance. You know a snail, like snail, the snail that we all know to have a shell and is very very slow in its movement. If you look at the snail, and if we try to judge it with our head, that is, without trying to precisely calculate its speed or its motion, if we just try to judge it with our head, it seems as if the snail is not getting faster, neither is it getting slower. As the snail is moving very slow like that, that is just how it is. Like, this is what I mean. Let's assume with some measurements, we found out that the snail is covering up about 1 meter. Okay, let's say we find out that the snail covered 1 meter within two minutes. That is, it took it about 2 minutes to cover up a distance of 1 meter. We will realize that in the next 2 minutes it will cover up another one meter. In the next 2 minutes again, it still cover up the same 1 meter. That shows that the snail is moving at a constant speed. It's not getting faster, it's not getting slower, because it's just covering up equal distance at equal time. So it's just covering up 1 meter every 2 minutes. So that is what uniform velocity actually mean. That's the velocity is not changing. I mean, it's not going faster, it's not going slower, it's just moving at the same speed. If it was moving fast, then it's just like that. If it was moving slow, it's just like that. Let's go a little into mathematics. This is the general formula for velocity, and this formula, as you can see in the screen, it says the velocity v is equal to change in s over change in t. We have v to be the velocity of the substance we are talking about. Change in s is the total distance covered for a given amount of time, and change in t is the given amount of time. Let me explain that. If we are actually measuring the distance covered by an object for a particular time, let's say for an amount of time, now that is the s, and that amount of time we are using to measure it could be in 2 minutes, 3 hours, whatsoever. That's the given amount of time we are actually talking about. Let's do some calculations here. According to what the experiment we did the last time, it said a snail is observed to cover a distance of 1 meter every 2 minutes. What would be the velocity of the snail? So let's do this. Now, if you can remember this particular formula that says to find the velocity of an object, it will be the change in s over change in t. Now, how are we going to find the change in s here? According to what this formula says, change in s is the total distance covered for a given amount of time, and change in t is the given amount of time. So now let's go back to this. We have our snail to cover a distance of 1 meters in 2 minutes. So it simply means 2 minutes is the given amount of time, and then 1 meters is the distance covered for a given amount of time. That is according to this formula. So now let's do our mathematics. Okay, and before we go on, I know many of us must have seen change in anything we see change in s or change in c, change in this, change in that. We always believe there should be an initial or final. But if we really get to understand what that change in actually mean, we without just memorizing it and memorizing, okay, change in s is final minus initial. If we really get to understand what it means, we are going to understand whether we need initial and final or not. That is, we will look at a question, and we'll know that okay, this one doesn't really need we don't need to start looking for initial or final. That's why I stated it. Instead of me just writing changing s as change in distance and changing t as change in time, I actually specified it here. So in this case, I would change in s as the total distance covered for a given amount of time, and change in t to be the given amount of time. And it would best explain this question. He said within a time of 2 minutes, it's covering a distance of 1 meter. So we already know that our change in s in this case is 1 meter, and our change in t is 2 minutes. So let's do our mathematics. Let's calculate it here now. According to the question, we have our change in s. We have our change in s to be 1 meter. That is according to what we got, according to what the question says. And then we have our change in t to be 2 minutes. And what are we looking for? Our velocity. And according to the formula, velocity itself is change in s all over change in t. So we can just simply say our velocity is what? Our change in s is 1, then that's 1 meters all over 2 minutes. This is 1 over 2. So what is it going to give us? 1 over 2 is the same as 0.5. So then what should be the units? Since we are measuring in meters and minutes, that is, we did our calculations in meters and minutes. So it simply means this would be 0.5 meters per minute. So therefore we say therefore the velocity of the snail, or let's just say the snail's velocity, will be 0.5 meters per minute. So that's our answer. Now let's talk about a non-uniform velocity. For a non-uniform velocity, the substance is not covering equal distance at equal time. The substance is either getting faster or getting slower. So that's about non-uniform velocity. If you can remember, for uniform velocity, the object was just moving at the same speed. But for this one, the object is either slowing down or is increasing its speed. And then it says an object which is getting faster is said to be accelerating, while the object which is getting slower is said to be decelerating. And in this video I'll stop here. I'll not go further, because if I should start talking about the mathematical aspect, I'll have to involve acceleration, and we have to get to know about it first. So that's what the non-uniform velocity is. That is, the object is either slowing down, like a car that is moving at the highway, and then the driver decides to match the brake. The car would slow down before it finally stop. That slowing down is what we call this deceleration. And it is said that is either is slowing down or is getting faster. So that is on non-uniform velocity. Maybe we'll see in the next video when it's time to discuss on acceleration.